Welcome back to the AIUK Public Policy stage. Our next session introduces a new analytics platform from the Alan Turing Institute's Public Policy programme, the Online Harms Observatory. It will combine large-scale data analysis and cutting-edge AI developed at the Turing to provide real-time insight into the scope, prevalence and dynamics of harmful content online. The Online Harms Observatory aims to help policymakers, regulators and civil society stakeholders better understand the landscape of online harms, something that's central to the draft online safety bill that's being discussed by Parliament at the moment. So in this session, we will hear why the observatory is needed, how we built it, and we'll showcase a monitor tracking abuse directed against Premier League football players on Twitter. This session will be hosted by Dr. Bertie Vidgen. Bertie is Head of Online Safety at the Turing. His research focuses on the use of artificial intelligence to find, monitor and stop hate speech, misinformation, extremism and bullying. Bertie has been a specialist advisor to the Draft Online Safety Bill Joint Committee in the UK Parliament and has worked closely with DCMS and Ofcom. Bertie is joined by Hannah Kirk, a research assistant at the Turing and PhD student at the University of Oxford, and also by a data scientist at the Turing, Angus Williams. However, the Angus Williams you'll see live is not the Angus Williams whose photo you may have just seen on the holding slide, which just goes to show that you can't always trust online information about who people are. So over to you, Bertie.
Brilliant. Well, thanks for that introduction. So the Online Harms Observatory. Now, just before we get going, I'm just going to give a little content warning. So I think we only show one tweet, which could be considered abusive, but also just fair warning that we do talk about abuse, hate speech, personal attacks and bullying, just for anyone in the audience. So the Online Harms Observatory, well, this has been developed by the Online Safety team, which is a part of the Public Policy programme. And our work really falls into three main areas. So the first is data-centric AI, where we're building, evaluating and interrogating different artificial intelligence techniques to find, monitor, assess and ultimately stop harmful content and activity, such as hate, misinformation, extremism, personal attacks and so on. We've done a huge amount of research in this area, actually, so if anyone wants to look at our papers, they're all online, they're all open source, open access. We try to share everything that we do for full transparency, and so all of our data sets, our code, our models, our annotation guidelines, you can find all of that and use it for yourself. Everything that we do in that work stream is then used for the Online Harms Observatory, which we'll be hearing a lot more about today. And that's this real-time platform that we've been building for about the last year or so, but it builds off years of research before that into different techniques for tracking and monitoring abusive content. The third area that we have is policy making for online safety. So there's a huge amount of amazing research that gets done every year, like really, really fantastic research that's done, and a huge amount of people who are working really hard to try and practically solve a lot of the issues that we see online when it comes to safety. But there isn't a huge amount of dialogue always between those two groups, and we're very keen that everything that we do is used practically to actually help solve the problem. So we want everything we do to be accessible, digestible, and usable, and that's really the goal of the policy making for online safety workstream. Now, let me just tell you a little bit about who we are. So my name's Bertie, I'm here with Hannah and Angus, but there are other people in the team as well. So we have Ealing, Scott, Pika, Helen, and Lila. We have more people joining us as well. And I'd really just like to say a huge thank you to everyone on the team who's done a tremendous amount of work to get us to where we are today, so that we can show you the Online Harms Observatory. It's been a lot of late nights, a lot of long weekends, and really everyone has gone way above and beyond to get us here. So big thank you to everyone. But into the Online Harms Observatory itself. And the first thing to say is that this is a joint project with the Department for Digital Culture, Media and Sport. We've been really fortunate they've supported with the funding of the observatory, but also they've been great partners, helping us to design the observatory, what it needs to do, giving us feedback on the functionality and the potential application. So it's been absolutely great working with those guys. We've also been working with Ofcom, and we've actually got a report coming out fairly soon on the data that we'll be showing you today, and it's been great working with them as well. So, the observatory. Why do we think that we need it? Why have we been spending so many late nights and long weekends working on this? Well, there's a real need for policymakers to have up-to-date, trustworthy evidence about online harms, because if you don't understand the problem, you can't start to solve it. We can't have better regulation, better policy making, more effective interventions without that evidence base. But it's not a trivial problem to get the right evidence that you need. The landscape of online harms is very complex, it's very fast moving, there's always new platforms, new actors, new types of content, and it's absolutely massive in scale, which we'll come to later on the talk. So there's a real need here for better evidence. And I think when we talk about When we talk about policymakers, we construe this quite broadly. So we're not just talking about DCMS and the Home Office and the Cabinet Office, we're also talking about Ofcom, the Met Police, parliamentarians, the Law Commission, Carnegie, other civil society groups, really anyone who's trying to solve this problem. We want to work with you, we want to help what you're doing. And so what is the solution that we proposed? Well, it's the Online Harms Observatory, a real-time dashboard giving insights into the scope, prevalence, dynamics, and impact of harmful online content. Now, I think it's worth saying that there are a lot of dashboards out there. Definitely, if there's ever been a solution in search for a problem, it really is the dashboard at the moment. So we put a lot of thought into whether we do actually need to build one, and whether there's anything out there already that we could just leverage and use. And to be honest, we didn't find anything out there that comes close to what we're trying to achieve in terms of scale and impact. And a dashboard really is, I think, the right thing to use here. And I guess it's also worth commenting on why we think we're so well placed to deliver this, why the Turing felt that we could do something really helpful and really impactful. And I think it's because we can combine the rigor and trustworthiness of academia, which is incredibly important, and like I said, everything we do is open source, open access. You can scrutinize it, you can tell us what we're doing right, what we're doing wrong, and then we can keep improving. But also we have some speed and flexibility. So we're not necessarily aiming at academic publishing cycles, which can be 2 to 3 years. We really are trying to deliver things in a timely way so they can actually be useful. Now, into the methodology. So I'm really just going to give a bit of a bird's eye view on how we build the observatory. Then I'll hand over to Hannah, who's going to talk in a lot more detail about the artificial intelligence component, and then Angus is going to give you a live demo, and then we can come back to some questions. But I thought it'd be helpful just to start with the methodology so that you understand how we're approaching this. So the first step is always to stream in data, and I think like a lot of academics and researchers, we are guilty of using Twitter a lot. But there are some good reasons for that. So we're very interested in public figures such as football players, MPs, journalists, and so on, and they are very active on Twitter. So it's a good platform to look at for that. The other thing is data access. We can access Twitter data, we can do so reliably and confidently, and all of the legal and GDPR and ethical constraints are fairly well understood at this point. And right now we're going to show you some work on Premier League football players, but we've already got work planned for MPs on Twitter where we've been streaming in data, and we've done some preliminary research on looking at the manosphere on Reddit. So those are our sort of next steps. But then after that, we're very open to feedback, and we've been looking at different platforms we can investigate, so YouTube, Gab, Telegram, MeWe, and if anyone has suggestions, we're always welcome to hear them. So once we've streamed in the data, we have to store it in our own engineering infrastructure. And this is, again, not a trivial task. This is surprisingly difficult to do when you have such big quantities of data and when you need to do it in a way that's compliant and lets you run all the analyses that you want. So this is just a very simple diagram to give you a bit more understanding of the technical side. We build everything in Azure. The Turing has got a great partnership with Microsoft, which is very helpful. And so we have our academic access to Twitter through the API. That then all goes into a NoSQL database, and then from that we have summary tables, and we use Python for data processing. So we write pretty much everything in Python. And that process has taken a long time to build out, and Angus and Lila have done a huge amount of work to make sure that we can really have confidence in our data. And I think it'd be worthwhile me just also describing a little bit what the data looks like, so this can feel a bit more tangible. So for the Premier League football players monitor, we have about just over 600 players that we're tracking. Those players have produced about 16,000 tweets in the last few months. So I think this goes back to the start of the season back in August. They've been retweeted about 7 million times. And then we have a category of content called audience contact, and that's something which we've come up with a name. So if you've never heard of it, that's totally understandable. But we define audience contact as any tweet which directly replies to a footballer, or which is an original tweet, so whether that's a standalone tweet or a quote which mentions them. This means we can be very confident that all of this data is directed at the football players. We can really be sure that it's not some other conversation that's going on. And we have about 4.3 million tweets, which falls into that bucket. And that content itself has been retweeted about 7 million times. Now, there's more content as well. There's other buckets of data that we have, but these are the main ones. And I think this gives you some sense of the scale of data that we're looking at in just a few months. So once we've streamed the data, once we've stored it in the secure servers, we then apply our Turing AI. And the question I always get is, well, why are you using AI? Like, isn't AI really problematic and biased and ineffective, and aren't there all sorts of issues with it? And there are plenty of issues with AI. I mean, we're very much critical of the use of AI as much as we advocate for it. But there's a very straightforward reason why AI is essential here, and it really is just a question of scale. You cannot handle millions of tweets that we're processing without using something computational and automated. And AI really is the most effective way of doing that. Any other technique that we have just does not match in terms of performance. So AI is definitely going to be part of the solution for how we monitor this sort of content. But then I often get asked, well, why are you building your own AI? Aren't there plenty of other tools out there? Aren't there things that you can use? And wouldn't that be much, much easier? And yes, there are. So there's a really very widely used tool from Google, Google Jigsaw. It's called the Perspective API. It's a free-to-use automated tool for moderation and research and monitoring. And it basically gives you a score for whether something's toxic or an identity attack or a personal attack. I think there's 18 different attributes, and it's in a whole bunch of different languages. So that's a great tool, and we've used that a lot. We've actually done a huge amount of research looking into the limitations of that tool and how it can be better optimized. And it's pretty good, but the problem is that anything that's out the box, off the shelf, is just not going to perform as well. It's not going to understand the context, it's not going to be able to be improved, it's not going to be able to account for the changing language that we see in these settings. So we will actually show a few comparisons against this tool later on, but we felt it was really important to build our own AI for this. And then the final thing is that we visualize the results. So I won't go into that too much because Angus is going to give you a great demo on that, but we started off using Power BI, again a sort of Microsoft tool, very straightforward, very easy, sort of like a codeless solution in lots of places, but we've ended up migrating over to Dash, which is a Python package from Plotly, and it's incredibly effective and it gives you a lot more control over all the aspects of the visualization, which was, again, quite important to us. So I'm going to finish up there. I'm going to hand over to Hannah, who can talk to you a bit about the AI.
Slide?
You want to go down on the clicker?
Cool. So yeah, thanks Bertie. So now you know why we're building the model. I'll tell you a little bit about how we built it. So most people hear the word AI and they think about some kind of model, some kind of algorithm, maybe even the Terminator comes to mind. But in reality, AI really consists of these two fundamental ingredients, of which data is one of those. We really need the data in order to be able to teach a model about the world. So this is why at the Turing we focus on data-centric AI. There's this wisdom in the field that if we put garbage data into our model, we get garbage predictions out. So our model is really only as good as the data we show it. And if we don't get this step right, we're not going to have a very intelligent or capable model at the end of our process. The problem is models can't really learn from raw data per se. So we have to have some sort of supervised learning, which in the field is basically that the data has to be labeled before our model can learn something from it. But equally, AI consisting of data and models doesn't exist kind of in this technical vacuum. So this is where the humans come in. We need the humans to be the teachers of the model, teach them about the patterns, behaviors, or in our setting, tweets, and how humans would process those kind of in the real world so that our model can learn from those labels. The big problem here is that human resources are really expensive. And especially for abuse, that comes not just from a financial cost of actually employing these humans, paying them fairly for their work, but also from a psychological cost. Repeatedly viewing really damaging and abusive language can be, psychologically scarring for these annotators. So the key question we're trying to answer with training this AI for the observatory is how do we best use these expensive resources, human resources, to teach our AI model about the distinction between abusive language and non-abusive language. So the form of AI training that we mainly focus on is called active learning. Now, active is the really key component here, and it basically means that we let our AI model decide exactly what data it wants the humans to label. So it can pick examples from a big pool of data to kind of tailor its own learning needs. So I'll walk you through this process with some slightly friendly diagrams, just so we get an idea of what we've been doing for the past couple of weeks. So we start with this big pool of unlabeled tweets, which was the pool Bertie was talking about, which has all of that audience contact in it. So around 4 million tweets. This is way too many to label manually. I think we'd still be not ready for AIUK next year if we took that approach. So how do we convert this big pool of tweets into some useful information for our model? Well, what we do first is we take a sample of these tweets from the big bucket, and we sample these using a combination of randomly selected items and also items selected based on a list of keywords which might be more aligned with abusive terms. Once we have this kind of sample from the big pool, we then take our team of trained human annotators to label these initial examples to tell our model whether they're abusive language or non-abusive language. Then we add these tweets to our kind of labeled storage of data, and we show them to our AI model, represented by this rather ominous looking emoji here. And this basically is to start teaching the distinction between abusive and non-abusive language. Once our model kind of knows something about the world, knows something about how language is constructed to convey abuse or non-abuse, we can now let the AI model itself pick the next batch of tweets. This is really crucial because then in each step, the model is picking exactly what it wants to learn from, the most informative parts of that big collection of tweets. And then we repeat this in an iterative cycle a number of times, so we're really getting the most out of our data in each iteration. So the real crux of active learning is letting our AI model decide exactly what data it wants to see at what point in time. So how does it actually decide that? Well, imagine we take our big bucket of tweets and we can represent the features of those tweets in 2 dimensions. It's a little bit more complicated than this in reality, but it's a good way to think about the problem. So here the little squares represent abusive tweets and the diamonds represent non-abusive tweets. So in reality, there's some line separating these 2 categories of tweets. And in the field, this is sometimes called the decision boundary. The big problem here is that we don't actually know exactly where this line lies, especially when we're scaling this up to millions or tens of millions of tweets. So the solution, like Bertie said, is to basically train an AI to try and predict or estimate where this line falls, how to distinguish between abuse and non-abuse. So imagine there's this green blob of tweets, and in that area our model is super confident that that's not abusive. So we don't really need to show it any more examples there. Equivalently, we could have this red blob of tweets where, again, our model really knows that if something falls in that area, it's definitely abuse. So very high confidence. Essentially, if we show our model extra examples in that area, it's almost like wasting resources or putting annotators at undue risk of harm from annotating lots of examples of abusive language. But what about these remaining points that kind of straddle the decision boundary? Well, one thing our AI model can tell us is, hey, I'm really confused. I don't know whether this is abuse or not abuse. It's kind of in a gray area. Now, in the field, this is called uncertainty sampling. It's basically taking the tweets that are very close to this decision boundary where our model is confused. It's really a toss-up between whether they're abusive and not abusive. So we can bring human annotators in to give us the correct or the ground truth label, and then from that, our model can slightly tweak what it knows about the world and slightly better estimate that decision boundary. The other thing our model could tell us is like, hey, these tweets are really different to anything I've seen before. Maybe they've got new terms, new hashtags. So if we select these items, we kind of expand the scope of what our model knows about lots of the decision space. And in active learning, this is called diversity sampling. So the bottom line here is we actually use a combination of these 2 types of sampling, diversity and uncertainty, to let our model tell us where it next wants data to be annotated. So in the process of building our AI, we were kind of constantly evaluating it qualitatively, finding some weaknesses. We actually found a few weak points, a few vulnerabilities where the model was lacking some robustness to some types of tweets. So in order to correct for these weaknesses, we also added an extra round of adversarial data generation. So adversarial data generation essentially helps our model helps our annotators to find the weaknesses and identify them before our model is deployed in the wild. So we actually want to find these edge cases and teach our model about them. So once again, I'll just walk you through the process. So we start again with some trained human annotators, which in our case was Bertie and some other people in our team. And the key here is that the annotators are tasked with tricking the model. So they're told to enter a piece of non-abusive content that the model will predict as abusive. So let's say this example tweet. The statement does use a swear word, but it's to describe the weather and not the tagged player. So under our guidelines, this would not be abusive. There we go. So we feed this example to our model, and maybe a poorly calibrated model actually sees this swear word, overfits to it, and predicts abusive, even though it's not targeting the player. Let's say in this case, our model actually wasn't fooled and it understood the nuance in who the target of this statement is. We also did the same thing in reverse, so to enter an abusive tweet that the model might think is non-abusive. So let's say our model doesn't pick up on emoji representations a bit like this one. So once again, we feed the example to our model to get the prediction, and this time we did trick the model. The important thing here is this tricking of the model is exactly the type of behavior that we want to trigger. So we want the model to make as many mistakes as possible to find these mistakes, because crucially what we can then do is retrain the model on its mistakes so it doesn't make them in the future, and essentially we're left with a much stronger and more robust model for deployment. So putting these things into practice, we start with our big bucket of unlabeled data, approximately it says 2.5 million there. I think we started this process a little bit earlier than the final counts. But before doing any fancy AI, we really have to take out the evaluation data. If we start doing active learning before we've taken out the evaluation data, we won't be left with the same distribution as kind of the big bucket of tweets that we start with. And we really need that because this is the bucket that we want to ultimately deploy our model over. So once we have the evaluation data taken out, we then can't start active learning unless we have a model. So we have to show the model some tweets as a starting point, a little bit of hand-holding before the active learning can start and before the model can start picking examples itself. So we take our initialization batch using a combination of random sampling and keyword sampling. Now we can start the active learning. We do 3 rounds, fairly small rounds each time, so just 2,000 examples. And this is good to do small rounds because it means we're really tuning our model carefully at each step and picking the most informative batches before retraining and repeating. Finally, to top up the model robustness, we add this little extra round of adversarial data generation. So all of these tweets are labeled by humans at each stage of the process, and then once we add them all up, we're left with about 13,500 tweets. And of these, 70% go into training, which we use to teach the model. About 8% go to validation, which we use to tweak the model hyperparameters. And the last proportion goes to testing, which means we can evaluate our model on totally unseen, held-out data. And in terms of splits, got about 15% abusive and the rest non-abusive. So I'm showing you this slide, not because I want you to read it, but just to note that a lot of organization and management went into this iterative approach, and that's not to be underestimated. I know Bertie mentioned the late nights and the long weekends, and that's definitely not an underestimation. So the reason it's so difficult to manage this process is that everything is stage gated. So we can't go back because at each round we're retraining the model based on the data it's already picked. And so because our journey is path dependent, you just have to be a little bit more careful to make sure you're not making any mistakes at any point along the way. Hopefully, as I'll now show you with some of the results, we reap the benefits of this iterative training by getting a progressively stronger model in each round. So that's how we built the model. Let's look at how good it is and hopefully see why all of this effort was worth it. So I'm going to start with accuracy. And accuracy pretty simple to explain. It's just the total number of correct predictions that our model makes over the total number of tweets. So we'll see later that it's not the best measure for our data set, and that quantitative results don't tell the full story. But it's a good starting point because it's pretty easy to interpret. So first, let's see how Perspective does, which was the model that Bertie mentioned earlier. So we use Perspective as a benchmark because it's well known, widely used, and it's just a good way to kind of sanity check where our model sits. So out of a test set of 3,000 examples, Perspective gets about 95% of them right, which looks pretty good. So our starting point is a pre-trained AI language model. It's a transformers model, if anyone wants the details. And it hasn't seen any football or abuse-specific training data. It knows a few things about English language, but not specifically in our domain. So it also does surprisingly well. Actually even does a little bit better than Perspective, even though it hasn't seen any abusive or football-related tweets. From there, we initialize our model with one round of data. That's just to kind of kick things off and get it started before we can do the active learning. Then comes our 3 rounds of active learning, and we get approximately a 1% increase in accuracy across those 3 rounds. And finally, we top it up with our adversarial data, which leaves us at around 97.5% accuracy. This means out of the 3,000 examples in our test set, our model only gets about 75% of them wrong. Sounds pretty good kind of at first pass. But on one hand, you might be thinking, okay, 97% accuracy, that's great. Seems really good. And on the other hand, you might be thinking, that was a lot of effort, kind of across all of this process. We move along the x-axis, a lot of effort for not much gain. Well, the problem here is right from the beginning, accuracy is almost saturated. So even a model that has seen any football or abuse-related data gets 97% accuracy. Why is that? What's the problem here? Well, accuracy doesn't take into account class imbalance, and our test set is 97% non-abusive and only 3% abusive, which roughly reflects the distribution of classes kind of in the real world on football Twitter. Oh, there we go. So a model can get 97% accuracy from just predicting non-abuse 100% of the time. That's a model with no skill. It just always predicts non-abuse. So in our setting where abuse is rare, we can't really use accuracy. We have to dig in a bit deeper into some other possible evaluation metrics. And luckily, for machine learning with class imbalance, there are some solutions, and these come from precision and recall. So precision is defined as, out of all the examples that we do predict as abusive, how many of them are actually abusive? This kind of gives the quality of our model. We can also look at recall, which basically asks, out of all of the abusive examples out there in reality, how many does our model correctly find? I feel like at this point in the presentation, it's been a bit of death by chart, so I'm not going to show you these repeat charts for precision and recall, but luckily there's a measure in machine learning called F1 score, which measures both of these goals simultaneously. And to save death by chart, I'm going to show you that instead. So again, it's been a lot of charts, but do notice here that the x-axis, the y-axis has changed quite dramatically. So anything on this chart represents much bigger gains than before. We were kind of going from 0.9 to 1. We're now going from 0.4 to 1. So with an F1 score, we can suddenly see that the performance is a lot lower at the starting point and a lot lower with perspective too. So now we take the class imbalance into consideration, the picture doesn't look so great. But over the course of our process, we see significant increases in performance far beyond what perspective is capable of. And this increase primarily comes from that precision score. So out of all of the examples that perspective predicts as abusive, only 35% of them are actually abusive. That's not a great hit rate. For our final model after round 4, the precision increases to 65%, so almost a 2x improvement there. Our model also does better on recall, so we really saw improvements across the board with our rounds. We can also evaluate our model with a precision recall curve. So this shows the trade-off between precision and recall at different thresholds. So to recap, Precision asks the question, out of all of the examples our model predicts as abusive, how many of them are in reality abusive? And we want precision to be high so that we have a low false positive rate, which is basically rarely predicting something as abusive when it's in reality non-abusive. And this is really important when we're talking about hate speech and abuse, to protect the right to freedom of expression and not be taking down legitimate content. In contrast, recall asks the question, out of all the abusive examples out there, how many do we correctly find? And this is relating to a low false negative rate. So we rarely miss abusive examples, and they rarely slip through the cracks of our model. So this is a trade-off, because if we increase recall, so if we move along the x-axis, we're starting to find the easy things initially. We're starting to find the easy examples that are out there. But as we kind of find more and more of those easy examples, we're moving towards the more nuanced stuff, the irony, the jokes, the more complicated examples. So inevitably, we start to get false positives in there where we're actually wrongly predicting abuse. So this is why these two things are a trade-off. This represents kind of the ideal scenario. It's not really a curve, but it basically shows that there's no trade-off between these two metrics that we care about. In practice, it's impossible, very, very hard to get here. But we can approximate that curve and kind of that corner and try and see how close we can get to it. So this is the base model without any data, training data, and you can see it does the exact opposite of what we want. It's literally an inverse of the corner that we were looking for. And it actually does worse than a model with no skills, so that model that always predicts the majority class, so always predicts non-abusive. So with one round of training data, we can already see big improvements. This curve is being pushed out into that corner, closer to where we want it to be. And after 3 active learning rounds, it's improved yet further. We're pushing it out, we're pushing that frontier out of what our model can do. And each time the line moves out, you can think of it as we're getting the same precision, but for more recall. So finally, with our last model, which was also trained on some adversarial data, we can see an even better trade-off. So if you look at the line around 0.8 precision, this is where our model kind of gets it right 80% of the time on predicting abusive. You can see the base model is just truly terrible. And then as we move to the round 0 model, we get about 20% recall. For the same precision at round 3, we're up to 50% recall, and our final model is up to 60%. I want to make one small caveat here that this was a pretty small test set, and it's also very imbalanced, so only 3% abuse, which does reflect kind of the real picture, but essentially it slightly weakens these quantitative results. They might only show part of the picture on how well our model is doing. It's important to note, as well as this quantitative analysis, throughout the whole process, our team has kind of been working day and night to test the model constantly along the way. So we also know that the model is getting better in qualitative terms as well. So for example, the round 3 model was not doing great at the distinction between criticism and abuse. The round 4 model was much better at that. So we've basically been iteratively exploring the model capabilities, and we can say with some confidence that we think this is now a good model. So now I've kind of shown you how we built the model, what it can do in training and testing. I'll hand over to Angus, who hopefully will show exactly what this model can do when deployed in production.
Thank you very much, Hannah. If you guys are not sick of charts by now, you will be by the end of this. Just waiting to see if we can get the This total tweets metric, that is the total number of audience contacts This is kind of just over this very fixed time view. If we want to dig a bit more back into the data over the history, we can then go to this history and trends page, which is showing essentially a lot of the same things that we saw before, but we also, I'm not sure if you'll be able to see it in this demo, but we have, essentially we can choose the date range that we want to look at data from. So again, we have these two timeline charts that will look a lot like the ones we saw on that last page, which I'll explain in a minute. And then we have this box on the side, which is showing total and average metrics over the time that you've selected. So you can see on the x-axis on both of these, it says date/time. So these are daily counts. On the top one, we have this gray filled area, and this is that number of total tweets, the number of audience contact tweets we were talking about before, alongside these two dotted lines, which are percentages. So the orange one is the percentage of tweets that are abusive on that day, and the blue one is the percentage of players that received abuse on that day. And on the bottom chart, we have pretty much the same, well, similar. We have the number of abusive tweets broken down by whether they are identity directed or not. And I think you might have already noticed here that there's two very clear peaks in abuse. As you can see, these two big spikes. And we can zoom in on this area on the top one. And we can see we have this, the gray line goes up, as does the orange line on both of those cases. Interesting, the blue line, which is the percentage of players that have been abused, that stays relatively flat, which suggests that this abuse is actually not being targeted at a wide range of players, but there's maybe very few players that are receiving a lot of abuse during this time. We can then explore this in the table down below. So if I go look for the 30th of Jan, which is one of those peaks, we can see that the top abused player was Mason Greenwood. And then if we look at the 8th of February, we can see that the top abused player was Kurt Zuma. These may be stories that you've heard about in the news. Mason Greenwood is involved in a sexual abuse case, and Kurt Zuma is involved in an animal abuse case. Clearly, these events have caused peaks in people trying to tweet at the players, increases in both people being critical of the players and being abusive of the players. These are things that we have trained the model to be able to differentiate between, and obviously the line between what is critical and what is abusive in this context may be quite contextual. Our aim with the dashboard is that we are presenting information, and it's up to humans how we interpret. So you might say, depending on what you think, you might say that peak in abuse is more interesting or less interesting. If we want to look at the data outside of those peaks, we can filter by the date we're looking at. So I'm just going to select this date, and this will update the graphs and the summary metrics and the graph below. And you can see the graph is now updated, and it's relatively a lot more even, less spikes than we had before. You remember before we had a relatively constant percentage of players abused during those spikes. But with this, we can now hide those other views, and we can see there's two very clear spikes in the percentage of players abused, suggesting that those days there are a lot more players out of the total number of players that are on Twitter who are receiving abuse. So that's a potential area you might want to investigate. Our next page of the dashboard is individuals and affiliations. So we've looked at things on a time basis, but we also want to look at them on an individual and group basis, because we want to know, which players and which groups are being more abused than the other ones. That's basically it. The main chart you can see here is what we call a scatter chart, and each point on this chart is one football player. We've filtered out some players, so we've only got the ones who are receiving the most amount of abuse. The axes of this chart, so you can see on the x-axis, it says the percentage of tweets abusive. So if a dot is further over to the right, it means more of their tweets are abusive. and the y-axis is the total tweets. So the higher up they are, the more tweets they're receiving. This is what we call a log axis, so it increases in scales of power of 10. So for instance, this gap to this gap, that's 9,000, but then to the next gap, it's 9,000. Yeah, I think you get the idea. And yeah, you can see there's two players, might be able to guess who they are, over on the right, who are obviously receiving a lot of abuse. This is again Mason Greenwood, who received 33% of abusive tweets, and Kurt Zuma, who received almost half, 50% abusive tweets. If we want to avoid those guys again, we can zoom this chart and we can look at these players. We might say this is a player we want to understand why he's receiving so much abuse. And then we can also zoom further into this one and understand what's going on in this big cluster of players. The next charts we have on this page, we've seen things on an individual basis. Now let's look at them on a group basis. So we can group players together, get counts of both the nationalities of players and clubs of players that are receiving the most abuse. This one's pretty simple. You can see that obviously the English Premier League contains mostly English players, so there's going to be a lot more hateful tweets, abusive tweets at English players than there are other kinds of players. Interestingly, we also see that Manchester United receives a lot more abusive tweets than other clubs. We can then break this down further in this next chart, which is what we call a bubble chart. So on the y-axis, we have each club, and this is ordered by the most abused ones. And on the x-axis, we have the countries. So, for instance, English Manchester United players receive the most abuse. This lets us really dig into seeing which players from which teams are receiving the most abuse. So I can zoom in and out of there. I think one interesting thing about this chart is it allows us to find cases where we have small players that are receiving huge, players from perhaps very unique nationalities or clubs, or unique nationalities rather, that are receiving a lot of abuse. So for instance, Gabon as a country here, there's only one bubble in this entire column, and we see it's there, and we see there's only one player who's Gabonese, who plays in the Premier League. If we want to understand what's going on with him, we can go into the table and we can filter by Gabon, and we can see his name, and we have also all these other metrics, and we now know also what the day was he received the most abuse, which also lets us maybe kind of take that away and look further into what's going on. Content, right. Obviously we've looked at time, players, now let's look at what's actually in the tweets. Because obviously, abuse is abuse. We want to know what the actual abuse is, or what is it in context of. So as I talked about before, we rank what are the most abusive tweets using this special score that we call the TF-IDF score, which is essentially a way of saying what are the tweets that appear more often in abusive tweets than they do in non-abusive tweets. As you can see here, we have, again, Kurt Zuma dominating. These bigger boxes represent the higher up, the more abusive hashtags. So for instance, Kurt Zuma animal abuser is the top hashtag. We can also hover over that and see more information about how that hashtag is being used. If we want to, again, avoid those peaks that we saw before from those two events, we can filter this by date, and it'll update. And it's interesting now we see these hashtags, a lot of these relate to specific football games. So for instance, Totliv is referring to a football game between Tottenham and Liverpool. And so that then gives us information as to understand what events are causing or correlate with the most abuse, rather. And then we have this graph down below, which is showing essentially how much the top 3 abusive tweets were used over time. So for instance, in this case, it's Manchester United FC, Maguire out, and NUFC. And this again lets us see when did these things peak, how can we tie that back into what's happening in the real world. That is the dashboard, as I've had to show it today. Obviously, the current scope of this is Premier League footballers, abuse, and Twitter. As Bertie talked about, we're going to be looking at MPs on Twitter. But also, we want, as he said again, we're going to expand. We want to look at other kinds of online harms, other targets of abuse, and that's our it's kind of the start of the journey, this dashboard, really. And I'll hand back over to Bertie.
Actually, I think there was a slight issue with the sound at the very start. So I think it's just been a request if you could go back to just the very first page, I think.
Yes.
And just do a quick, just basically repeat, I think, that first
Great,
part.
okay.
Yeah.
This is the quick view page. This is the first page, the main page of the dashboard. This page is intended to give people a really high-level, accessible view of what's been happening, the prevalence and trends of abuse against footballers in kind of the recent past 24 hours and past 7 days. You see these two boxes on the left, which represent a collection of metrics over those two time periods. And we also see these graphs over to the right, which we would have seen before, so I guess I don't need to go back into those again. But this is over the last 2 days, every half hour. The metrics that are contained within these boxes, Bertie talked before about audience contact tweets, which are the tweets we want to look at to see if they are abusive or not. So the total tweets there represents the total number of audience contact tweets that footballers received during the past 24 hours. Likewise, if we apply our AI to those, we can then identify which ones are abusive. So for instance here, 318 were abusive. We can get that also as a percentage, so 6.6. We can also look at which of the abusive tweets were identity directed. So in this case, 33 over the last 24 hours. We can count the number of players that received abuse, so they've received at least one abusive tweet over that time period. And then we can also see which player received the most abuse and which hashtag was used most frequently in abusive tweets compared to non-abusive tweets. And so we see this for the past 24 hours and the past 7 days, and we also see these change metrics. So for instance, over the last 24 hours, the number of total tweets has almost halved. The number of abusive tweets, again, has almost halved. But in the past 7 days, we've actually seen an increase in total tweets and almost doubling the number of abusive tweets. I think that pretty much covers it. Is that right?
That's brilliant. Thank you.
Back to Bertie.
Awesome. So I'm just going to quickly, I hope you can see these slides, but anyway, they're not super important at this stage. So next steps, we're going to be expanding the observatory. We're going to be doing more live updating, new AI models, and also increasing and expanding the functionality. Always looking for more people to work with us, so please do reach out. And to do so, here are, oh look, it's zoomed in. Here are our contact details. So email any of us or tweet us if you like, and we'll be really happy to pick it up. I'm just going to go to the Q&A in our last bit of time. So I'm going to start with a question which I think I'm probably best placed to answer, and it's the most upvoted question. So how does your team manage subjectivity in human annotation? Abusive can be relative to each individual, community, and culture. That's absolutely the case, and it's really tricky working with these sorts of concepts. Abuse is inherently subjective. Everyone has a different view on it. Everyone draws the line between abuse and not abuse in a slightly different place. And also it's very contextual. So often the things you need to understand to appreciate whether something's abusive or how abusive it is are things like the speaker, the setting, who they're speaking to, their intentions. And those are often things that we just don't have when we look at tweets on their own. So it's very tricky. There's also a lot of work which shows that there are systematic differences. So we know that, say, people who have been abused themselves tend to be slightly more sensitive to abuse, let's say, or if you're of an identity which is frequently attacked, then again, you might be more attuned to abuse than if you're someone who's never had those experiences. So there's lots of different factors at play. We generally just try to take the approach of we're very clear where we're drawing the line. Now, that doesn't mean we're always drawing the line in the right place, but you know where it is. It's all in our annotation guidelines, it's all in our documentation, and then we basically just want to get our data labeling as consistent as possible. Because the more that our data is consistent, the better the machine learning tool is that we can train. And again, even if it's not quite drawing the line in the right place, at least you know where it is, and then we know what the tool's doing, which is always the first step. But yeah, no, really, really tricky question, and one that we think about a lot, I have to say. I then got a question for Hannah. So, do you envision, here we go. Do you envision the model trained on football hate speech can be fine-tuned for other forms of hate speech, or is the plan to train individual abuse models?
Yeah, this is a really good question, because even though we've kind of started on football Twitter, mainly after the Euros 2020, a lot of the news about that was about racism in football. It's not our endpoint, so we really want to be able to focus on a wider scope of targets and a wider scope of types of hate and abuse. And I think next we're thinking about focusing on sexism with MPs and in politics. And there definitely are some shared aspects between different targets of abuse on Twitter. But really importantly, there are these, unique lived experiences. We're not saying that the two things are the same. And even in the language that's used to target different groups, that the features of that language can vary quite substantially. So what we're doing at the moment is essentially trying to trial some knowledge sharing between our different tasks. So humans can really do this quite seamlessly. We can do one thing in the morning, not do it again until the evening, and have no problem remembering what we did that morning. But with AI, we have this problem called catastrophic forgetting, which is essentially when we show the model new data on a new task, it kind of forgets how to do the old task. And that's what would happen if we just kind of actively set off on the new data with the model we have now. And we have to do something a little bit more fancy. And at the moment, we're looking into kind of insights from transfer learning and continual learning, lifelong learning, which it's sometimes called, where we're essentially trying to share parts of the knowledge across our models. So the bits that are useful from the football data set for the MP's data set, we really want to share those weights, share those connections, and make sure we're not kind of retraining things that our model already knows. And then on top of that shared knowledge, we'll also train for some specific knowledge, which kind of applies uniquely to either of these target groups. So yeah, that's kind of our next step, is to really focus on this knowledge transfer between groups so that we don't have to retrain a new model every time.
Awesome. I'm going to answer a couple of relatively easy questions before handing one over to Angus. So someone's asked here about, are we doing any work on memes, images, videos? The answer is not right now in this version of the observatory, but we have done quite a lot of work on hateful memes and images before, and we definitely want to incorporate that. So there's a few papers that we've got which are out there. Someone else has asked about it being open sourced. We do try to open source everything that we can. Because it was quite a push getting everything in time for this, so we haven't yet got it on GitHub, but that will be one of our next steps. And all of our other research is on there, and all of our data sets and everything. So we have it all as well on our own website, where you can kind of just see it all in one go. So yeah, question for you, Angus, which has of course disappeared, but I'm sure I will find it again. You're going to have to get my dodgy remembering of this question. So, someone asked something about looking at, oh no, here we go. Are you planning to add any features to map how abuse spreads based on retweets, etc.?
Yes, so in addition to audience contact, which we talked about before, as a type of tweet that we collect, we also collect tweets that we call audience contact engagement. So tweets that are targeted at footballers, we're also collecting things like retweets, likes, replies, those kind of numbers on those tweets. So we're able to see what kind of content that is targeted at players is being interacted with most, and then seeing how much of that is shared. And there's a possibility down the line of working on some kind of network analysis that we're able to trace how that abuse spreads. But for sure, there's some degree of that we are already able to do, and some to a greater degree later on.
Awesome. And there's another easy question here that I'll answer. Someone's asked about, is the model also able to identify abusive tweets employing self-centered abuse, e.g. intentional misspelling by users attempting to avoid being flagged? And this is definitely a problem. So there's this kind of this widespread practice of, say, just swapping around letters or replacing a letter with an exclamation point or some not a letter. And that can be really effective at tricking a lot of AI systems. It's actually amazing how these very, very simple adversarial perturbations can make a huge difference. We do train the system to be able to account for that, so it's very robust and consistent across that sort of data. This is also where adversarially generated data can be really helpful. So that's when we have humans in the loop trying to trick the model, because that's a very easy way to trick the model on like round one, but then it's very easy to retrain the model to address for it. So that's something that we can do. Another good question here. So how is this different from off-the-shelf social media monitoring tools on the market today? I might pose that to you, Angus. So how do you think this differs from, say, something like Brandwatch or one of the more like generic social listening tools, as they're often called?
Yeah, sure. So you've heard about the kind of rigor of the methodology by which our AI has been trained, and it's all well and good collecting things from social media, and you can infer a certain amount of what the content is from using non-AI based methods, but with the kind of cutting edge research that we have been working on, we're also able to then apply that into our tool, which is something that wouldn't be available to the same degree in those kind of tools.
Yeah, and even things like putting out audience contact, lots of tools just give you a dump of tweets, and they're like, here you go, here's 10 million tweets, and it's like, well, you need to break them down into all the different types because they all pose very different challenges, need to be processed different ways. So there's a lot of things we're doing. I'm aware that we've come to time. Do we finish up at 5 minutes to, or do I keep going? No? Someone's saying I'm done. We're done. Thank you very much. Yeah, thank you for listening. This has been great. And big thanks to everyone at AIUK for putting this on. Thank you.